Fifth question, part A. Consider the following reactions. Now there are two reactions. There is a solid, which means hydrated solid of carbonate of M metal, M CO3 2 dot NH2O. It's a solid. It thermal decomposition giving carbonate of it and water vapor, water gas, and this carbonate 2 thermal decomposition as an equilibrium giving the oxide of dioxide of M and carbon dioxide. A small amount of it says it's 0.1 mole of M carbonate, or the hydrated carbonate of M is present in an evacuated rigid container volume of this value. There is a container. In this one, this hydrated carbonate solid is present, and the volume of this container is given, this value. And how much of present? 0.1 mole of this one. And the temperature of the container was raised to 400 Kelvin. It means initially it was below 400 Kelvin. Now the temperature is 400 Kelvin. It is raised up to 400 Kelvin. The metal carbonate doesn't decompose at this temperature, but the crystalline water evaporates completely. This is what? Crystalline water. This is crystalline water. This is the metal carbonate. Now you understand that decomposition of metal carbonate, it means this one, solid plus 2 carbon dioxide gas, doesn't happen. This is this temperature 400 Kelvin. Only evaporation of the crystalline water do happen, giving its carbonate and water vapor at 400 Kelvin. The pressure of the container was measured to be 1.6 into 10 to 4. Now there is a pressure in the container. Now pressure is usually given by a gas. What's the only gas present in 400 Kelvin? Water vapor. Yeah, there is no other gas present. Therefore, this pressure 1.6 into 10 to 4 Pascal is given by this water. Right? Water form. Volume occupied by the solid is negligible. What's meaning of that? We can consider the volume of the gas distributed in the container as the volume of this V. The volume taken by this solid or crystalline solid or the metal carbonate can be considered negligible compared to the volume of this V. Otherwise, this value should be subtracted from the volume of the container. Right? We are asked to just neglect it. Then, what asked is determine the value of N in the formula. This one. This N is asked. This is what asked. How do we find it? Then, first, the pressure of the container is given as 1.6 into 10 to 4 Pascal. Can't we apply PV equals nRT here? Since pressure, volume, R and T is known. Then find total number of moles. We can find. Then total number of mole will be the mole of H2O gas. Then I am substituting the values here. Total pressure in the system at 400 Kelvin is 1.6 into 10 to 4. Volume is given 8.314 into 10 to minus 2. N are 8.314 into temperature 400 Kelvin. Right? From this one, N can be found as number of total moles in the system as this value 0.4 moles. But this is not now. N is this one. Don't mix up with this N with this one. This is N total. This N total. Right? It means total amount of mole will be the moles of water vapor formed. It means 0.4 amount of water vapor has been formed. And in the meantime, what's the moles of crystalline water evaporated? It will be 0.1. Right? From 0.1, 0.4 has been formed. That is in concordance with stoichiometric ratio. What's the stoichiometric ratio? And that stoichiometric ratio and amount of reactant and amount of formed value of crystalline water and water vapor should be equal. What are the ratio? What are the stoichiometric coefficient ratios of these two? There is one here. 1 to N ratio should be equal amount of reacted of crystalline water 0.1 to amount of H2O gas formed 0.4. We knew that N total equal to only the moles of H2O. From this one, N can be found as 4.